Okay, good afternoon again, everyone, and welcome to our webinar. This is waste webinar. It is only for the waste sector in the Ecoinvent database and aims at giving you a complete idea of changes that have been performed and published in the latest version of 3.9, but also give you an insight on the future of what you or other users can expect to see in the Ecoinvent database, again related to the waste sector. My name is Avram. I'm a project manager, and together with my colleague Nora, we will be your hosts today. Some information about the webinar. You are all muted. If you have questions, you can type them in the box. There is a box in your application there. So at the end of the webinar, we will have time to answer questions. And if questions are left unanswered, then we will collect them and reach out to you with private emails. After the webinar, you will receive a questionnaire to evaluate your today's experience and also get the chance to propose modifications or make proposals about new webinars, about content you like to see from us, or other topics. So please take the time to fill this in. We will really appreciate it. Otherwise, we will be sending you the slides of today's presentation. And we will also upload the recording on YouTube channel of the Ecoinvent Association. So without further ado, I'll move to the structure of today's webinar, where I will first introduce the Ecoinvent Association. I will give an idea. I'll try to give you an idea of what is the Ecoinvent database, mostly for newcomers. And finally, I will, most of the time, I will talk about the waste sector and the updates of the waste sector performed this year, but also what is coming up in the future. So the Ecoinvent Association, we are a non-for-profit association. We are dedicated to promote the availability of high-quality data for sustainability assessments worldwide. The association is founded by 5 Swiss research institutes, which you can see here. We are a growing team, currently 36 people, based in Zurich, Switzerland, and most of us are dedicated in the technical team, where we have LCA and LCI experts. We have an IT team and also commercial and communication teams. You may know us best as publishers of the Ecoinvent database, where we maintain, we update, and we publish the Ecoinvent database. But we are also service and knowledge providers. Now, the database itself is a global library of human activities. It includes thousands of processes alongside the value chain across all industrial sectors. We perform yearly updates on this database, and the database itself is trusted by over 8,000 licenses, representing tens of thousands of users from more than 80 countries. Of course, the database is compliant with ISO 14 series. Now you can also see some LCA software applications that they are compatible with our database. And also you can see some business software applications with LCA features compatible with our database. The database content, it has roughly 19,000 activities, around 4,000 products, as it was published this October, version 3.9, covering all regions of the world. And we also have several several sectors or that covering human activities like crop production, electricity production, resource extraction, metal forming, transportation, and waste sector, which we will be talking about today. Going deeper into the database, we have the waste sector, where it links to all other sectors through the waste generation of various activities. It comprises of more than 1,800 datasets. The database has a library of more than 270 unique wastes, and the geographical coverage spans in more than 50 countries. To clarify here, one dataset is an activity, a process treating a waste or a wastewater within a given geography with a certain technology. For example, a sanitary landfill of municipal solid waste in Switzerland is one dataset. There are several treatments available in the database, such as thermal, mechanical, or biological treatment. And the vast majority of our datasets are made with our waste model. The model works based on composition of the waste and the selection of the technology for the treatment of waste. And you use these two information as inputs, and as output, you receive a data set of a treatment of a waste. The major challenge the sector has up to today is the aggregation of treatments. The design solution is disaggregation, and disaggregation is a larger project which we started, and we publish now the first results with version 3.9, which includes the disaggregation of all wastewater treatment datasets. Room for a small definition here. Aggregation is a process of combining several treatments together. By aggregation, we mean that one dataset is a treatment dataset can generate wastes, and the treatment of these wastes is combined with the treatment of the original waste. So all in all, you have several treatments together in one dataset, and the waste being produced from one treatment are not visible, are just part of the aggregated dataset. These can have several, it may bring several advantages on a background database. However, it has numerous drawbacks as well. As an illustration of what it means, the aggregated dataset, this is a dataset in an aggregated form. It just defines a wastewater treatment of a wastewater in a random geography here. What you can see, well, actually you cannot see. What you cannot see is that all the processes that follow are actually merged into one dataset, and this does not allow you to see all the details. Waste disaggregation now, which is the solution we designed and already implemented this year, it looks like this. On the first place, you don't have any more one merged dataset, but you have the wastewater treatment that generates certain wastes that in turn are treated in separate processes, and in turn those processes generate further wastes that again are treated in other treatment processes. So what does really disaggregation improve? What does it give? The answer is transparency. It's quite easy here. Waste byproducts are now registered and is visible for users. You can see both quantity and also quality of these byproducts. By quality is meant that you can see the elemental composition of the new wastes as well. The wastes are treated in separate processes, in separate datasets, and between the processes there is a market to account for the transportation of this waste. All in all, system boundaries are respected in terms of space and time. And finally, the disaggregation is as well fostering the idea that that the waste can be seen as a resource. Now, what is the value of all this? First and foremost, while using the sector, you have a better understanding. You see a new wastewater treatment, and you know, for example, that emissions in this data set in the wastewater treatment are only emissions taking place within the system boundaries of the wastewater treatment plant. So there is more comfort when interacting with the database, as things are more clear and more transparent. And you can see the baseline assumptions from us about how a waste generated by treatment activity, how this waste is treated. You can also don't agree with our baseline assumptions. So with the disaggregated datasets, you can actually change these assumptions we have now. By saying this, it means that it leaves you space to model your specific waste scenarios, including regional parameters such as regional collection and transportation factors. You can take them into account now with the disaggregated datasets. Finally, you can perform actually a meaningful contribution analysis on your product. You can say my product or my service has an impact of X%. This impact is due to my waste. And then you can further see that a percent of this impact of the waste is actually the waste produced by my waste. Now, the disaggregation for this year brings updated wastewater treatment datasets. So everywhere that there was a wastewater treatment is now replaced with a new dataset. Overall, 63 new wastewater treatment datasets have been disaggregated, and now the 63 new datasets account only for the activities that take place within the system boundaries of the wastewater treatment plant. As an addition, we have wastes from the wastewater treatment plants, and 158 activities are introduced to handle the waste byproducts from the wastewater treatment plant. And those activities can be either incineration or land farming or landfill of sludge for the several byproducts the wastewater treatment plants can have. Additionally, there are 120 datasets that refer to handling the waste byproducts from the incineration. And those are residual material landfills or slag compartments. And those wastes refer to bottom ash or incineration residues, for example. Wastewater markets. Here we got some new methodological updates. First time introduced this year in version 3.9, we now include losses of wastewater in the wastewater markets. In all parts of the world, all the wastewater that enters the wastewater treatment plant is not fully treated, and the wastewater thus is directly emitted to the environment. On top of this, wastewater produced is sometimes not reaching the wastewater treatment plant. So all this together, we have implemented in version 3.9 For the first time, we model wastewater losses within the wastewater markets. The elemental composition of the wastewater is matched with emissions to the environment, and the amount of emissions depends on the amount of wastewater that is not treated on an average number per country. For example, in Europe, it is assumed that 12.7% of the wastewater is lost and not treated, and this value is recorded in the European markets for wastewaters as losses. Now, wastewater treatment plant classes and their infrastructure. Generally speaking, a wastewater treatment plant has a need for infrastructure. And I'm not sure you remember the old system. We had wastewater plants with 5 classes in terms of capacities, meaning how large is the plant, how large is the volume of wastewater it can treat. This we have deleted, and we now use 2 new classes to refer to urban and rural settings. Each wastewater each wastewater treatment dataset is therefore an average situation of these 2 classes for every country. Now, the naming convention, the disaggregation inevitably generates new wastes, and generated new activities, new treatment activities are introduced to handle all the new wastes. So there is a need to introduce a consistent manner to name the activities. So the activity names which refer to the treatment names, they now have 3 elements. And first element is, see the red color, first element is the name. First element of the new name is actually a term introducing the fact that this is a treatment dataset. Second part, which is the blue part, is the name of the wastewater itself, and the final part with the green color is a suffix that clearly defines the technology of the treatment. For example, here you can see all the 3 elements together. We have a treatment of a wastewater, average, and this is treated in a wastewater treatment. Now, the new naming convention allows users to efficiently search for various treatments or various wastes, depending on what each of you want. For example, going from a top-down approach, you can look for all the treatments available in the database by simply searching for the term treatment of. Further, you can actually check all available treatments that they are specific treatments for the wastewater average by just selecting or searching for wastewater average. And finally, you can find all wastewater treatments treating several wastewaters, for example, by just looking for the term wastewater treatment. Coming next, in the naming convention, we have waste and wastewater names. In a similar manner, the disaggregation has generated new wastes within the database, and their names are again designed in a manner to be consistent and give actually the waste treatment chain where they came from. Again, the new waste, they have the new waste names. They have 3 elements. And first and foremost, the name of the waste itself with the red color. The second part is actually the treatment chain that this waste was generated from. And here you can see that there are some capital letters, some abbreviations that are separated with a dash. And on the third element of the naming convention for waste is actually the original waste or the original wastewater that this waste came from. For example, you see here there is bottom ash from municipal waste incineration that is linked with a wastewater treatment that initially was treating a wastewater average. You can see here a list of abbreviations that you can find connecting the treatment chain of the waste. And what is a good indication here is that when you see abbreviations in wastes or wastewaters or waste treatment activities, when you see the abbreviation is a sign that this waste was generated specifically in another treatment activity. All the information about the new naming convention, you can find them in the report of changes which we publish alongside the release of version 3.9. Now, some other updates we launched for 3.9 is the product information for waste. Product information is a new feature in the database, is essentially a piece of documentation that covers all products and all waste in the database. It gives a description of them in order to increase the comfort you or other users feel when interacting with the database. We launched this project last year in 3.8, and in the recent version this year of 3.9, we've also published the product information documenting all the wastes in the database. In this slide here, I have the product information for municipal solid waste, and this is specific to municipal solid waste. So, and the first information we give is we classify the waste into four categories. Is it a residential waste? Is it an industrial waste? We give this information on the first place, and we also mention activities that this waste can be generated. In this example, the generation comment is a rather common one, but because, as you also know, municipal solid waste is generated almost in every human activity. Next piece of information given in the product information is if the waste is a combination of different fractions. And here if it is, we analyze the fractions here and we list them all, and then we give some physical properties of the waste, such as the water content and carbon content, calorific value, etc. Here, what you need to pay attention is the phrase that says database default, by the database default, and then the physical properties are listed. Here, what this means is, as you know, municipal solid waste is not the same as in Switzerland and in France, for example. It's not the same. And I'm talking here purely on an elemental composition basis. So the two wastes in the two countries are not the same. The information, therefore, we exhibit in this product information refers to municipal solid waste as a global average, as we have it in the database. It is possible for you to find the difference and the different regional elemental composition of the waste by looking into the properties of this waste. And for this, in order to do this, you need to find the dataset that is treating this waste in a given geography, and then look into the properties. So, for example, if you consider waste water treatment in Switzerland, and you go into the properties of these datasets, you'll find the Swiss specific elemental composition of the wastewater. Next, we give here the information about the generation of the waste and whether this waste is produced or is generated by an ordinary transforming activity, or it can be generated by another waste treatment. And this is a crucial point for you to consider when you are about to select a waste for your study. Further, we give the treatment options of this waste in the database, and this simply means what treatment we have available for this waste. In this particular case, we have deposition, which can be sanitary landfill or unsanitary landfill. We have thermal treatment, which can be incineration, or we also have uncontrolled forms of disposal, which is open dumping or open burning. Based on these treatments, we provide the classification whether the waste as is a hazardous or a non-hazardous waste. Further, we give this information in addition to how it's treated. We also say how a waste is used in the database. And here, please mind the wording. For example, municipal solid waste can be used in clinker production, and we don't list clinker as a treatment, but we rather say that waste is considered, for example, as fuel for the clinker production, and that is why it is termed here as it is used. And next, it's quite an interesting piece of information that helps you understand better how you can model the waste. It's basically a proposal we make to you on how to use the waste. Here you have two levels that you can use these two levels to model the waste. The first level is a treatment activity, and the second is a market activity. So for the first level, for the treatment activity, you can, for example, select a sanitary landfill of municipal solid waste. And that's just a certain technology for a certain waste in a given geography that's set. Then you can, on another level, select a market for this waste, which will give you a mix of several treatments. For example, a market for municipal solid waste, which is the same waste in Switzerland, will give you an average mix of treatments for 1 kilogram of municipal solid waste in Switzerland. So it can have several treatments coming into this market, and this can be municipal incineration, it can be sanitary landfill, etc. Next, you receive information. This is the final piece of information actually you get, which is a clarification about transportation. If you pick a treatment, data set, then it means you need to model yourself the transportation distances of your waste. Otherwise, if you select the market level, it means that transportation and collection is accounted in this market, and therefore you don't have to include it. But we still recommend that you can inspect the transportation distances, and then you make your mind whether you agree or disagree with these transportation distances. And also, this is the case where you can modify and say, I have specific transportation distances for my waste, for my area, for my country. This is the place where you can add it. Product information is available in the database overview through our website. Now, for the future, we have some very cool plans. First and foremost, we have a plan to complete the waste disaggregation with the rest of the solid waste sector for version 3.10. We believe that the disaggregation will bring you a whole next level of transparency, which is in line with our vision to offer high quality environmental data. And so this we are committed in doing for the next year. And on a second note, we want to continue and maintain the product information. We believe that it aims at providing comfort when you or users use the database, and we believe this is achieving it, so we are committed in maintaining this. Now, for coming up next, we have some aims on the waste sector. First aim we have is to better represent technology and to better represent the regional variation of technology. Consider, for example, two countries like France and Switzerland. How much of a waste is incinerated with energy recovery, or how much is incinerated without energy recovery? It is not the same in both countries. And we aim at picturing this type of information for every major geography in the database. Further on regionalization aims, if I say, we want to better reflect the regional composition of wastes across countries. And like I said earlier, the elemental composition of a waste is not identical between France and Switzerland. And this can have an actual impact in the treatment datasets and therefore in your studies. Finally, we aim at better covering recycling in the database. Recycling is a major part of the waste sector, and we would really like to do more and give more and better quality data. I just need to make a small disclaimer here. All the 3 points you see in this slide are aims we have and are currently in the designing phase. So we don't have any commitments to offer on when or how exactly it will be available in the future. And I think that was all. Yes. Thank you very much for joining this webinar. I hope you now have a clearer view on what we've changed in version 3.9. And I believe also you have a good idea of what is coming in the future, or what we wish to implement in the future for the waste sector. Yeah, like I said in the beginning, you will receive a survey request, and we appreciate you filling it in, spending a couple of minutes, and you evaluate your today's experience and give ideas on upcoming webinars. I will just leave this here. You can scan it. It's our list of upcoming webinars. You can check this out if you want to participate in our future upcoming webinars. And in the meantime, we can proceed in checking a couple of questions you may have from this presentation. Okay, no, there's one question. Wait a second. Okay, so there is a user asking for the future plans. Recycling is planned to have different allocation method includes it, e.g., for example, cutoff, PEF, EPD. That's actually a tough question because today's presentation is a content presentation and is irrelevant of system models. So how the content will fit into the the system model is a whole new discussion, and we haven't started this, to be frank. There is an off-topic, but yeah, an off-topic question. I unfortunately missed the general introductory webinar. For the Ecoinvent beginner, is there the chance to get access to a recording or the slides? Yes. The slides, you will need to reach out to support, I think, and we will send you the slides. But if you go on the YouTube channel of the Ecoinvent Association, you can find there all webinars we have performed in the past, and in a couple of days you will also find today's webinar. There is another question. Do you plan to implement the industrial incineration disaggregated, for example, cement industry? Well, that's actually, let's say, cement industry or clinker production doesn't fall precisely in the treatment in the waste sector. It's more, like I said in this slide, that the waste itself as deemed as a fuel for the clinker production, and in that sense, we don't. I'm not sure we can actually disaggregate this there. It's already a very it's a different type of modeling that encompasses the construction sector. So maybe I can transfer this to my colleague that works more closely with construction materials, if that would be okay with you. Yep. Otherwise, we don't see other questions. I hope you have better idea now of the waste sector updates and what's coming in the future. For anything you have questions, you can always reach out to our support, create your own ticket, and me or our colleagues will do their best to help you out. Thank you, and have a nice afternoon or a good day wherever you are.